Good. Okay.
Thanks for coming in tonight. Our talk is, as you can see, and it's going to be given to us by Clariza. So Clariza, if you'd like to introduce yourself.
Hi, my name is Clariza. I'm a DevOps and platform engineer at Navitas at the moment, and I specialize in doing DevOps in the educational integration systems, because that's where our niche is. I'm experienced in doing serverless deployments, a bit of scripting as well, and cloud automation, as well as I've dealt with a few Kubernetes management before with OpenShift. And I was previously an All Builders Welcome grant, and that's the reason why I know a few of the people who are in the Perth AWS community. And right now I'm expanding into solutions architecture because it seems to be an important part as well when you're learning DevOps and software engineering in general. It's really good that you learn the design on how to, on designing the systems in a way you understand how to optimize the processes within it. So thank you for coming over. So my topic for today will be about building and deploying containerized app using infrastructure as code with AWS CDK and Kubernetes from AWS as well, which is EKS. Has anyone have done some DevOps before, like CI/CD pipelines, GitHub Actions? Okay, that's half of the room. Yeah, so my topic would be a little bit more like the basics of DevOps, but this is more of like how we think about DevOps, especially if we are developing applications. So when I was, about Navitas, so just to give you an idea about what we're doing at Navitas, so we have this different integration systems. We're dealing with school systems. We also have our own systems, and a few of them are actually enrollment platforms, learning management systems, scheduling systems, and a bit of them are like reporting systems which involves data. For the DevOps side of things, one of a few challenges that we have is scaling, where whenever there is a lot of students are enrolling, our system somehow needs to have that capacity to scale. So the DevOps team needs to handle all those things that is happening whenever there is a peak of traffic coming in. We also have to have the process of how to deploy quickly. So if you have this application, especially when you're starting, or whenever we have a new microservice or application as well, and then whenever we want to deploy it to production, there should be a process that is standardized that developers can follow once we handed it over to them. So technically, we're the one building the CI/CD process for them, while they're busy building their apps. And it's not a lot. I mean, our team is small, about 4 of us. And then we want to make sure that we're maximizing our energies in the way where we allocate our time to the best, or our time to the most efficient task that we're doing, especially in terms of DevOps. Because once we do a task or a process, we give it, or we train the developers on how to do it, and they will handle it themselves. And whenever there are problems going in that they're not familiar with, then we support them. Now, before moving to the actual DevOps thinking, I was just wanting to tell you a story about how I started with DevOps and how I moved forward along. I'm not yet probably on the senior level, but I'm learning much of it in a way where I didn't learn from university or just talking to people. I learned it the way, like it took me experience to really learn from it. So there was this task that I was given where I need to obfuscate production data. So it's an actual data which is a critical one. And the developers need to use it. but they cannot view the data, so it needs to be obfuscated. And it's a big information that is in a terabyte size of database, and it needs to be transferred to the non-prod account from prod. So at first, because I was new, I was just starting it with Lambda. So the serverless spectrum actually gives us an idea of how we approach architecture in terms of the DevOps side of things. So like for me, I started with Lambda and tested it out. I realized that Lambda has only 15-minute limit in terms of processing things. And my data is big. And I realized that the data was actually, it takes 3 hours to obfuscate them. So translate them into something that it's still readable, but a random letter, not a real actual data. So the Lambda wasn't working. And then eventually, like, I realized like maybe we can move to something that will take off the 15-minute limit. So I moved to ECS Fargate. And the senior was agreeing that, yeah, it can solve the 15-minute limit, which actually have solved that one, and I was happy with that. And then, and the senior actually suggested that maybe you can try out, although it's performing well and it does the job, so it's working, it can obfuscate the data for 2 to 3 hours. How about let's try EC2? So we're moving towards that side, that side from that. And then we're not testing out the performance here, we probably test out cost, maybe it's cheaper. So when we test it, and that's where I realized like, you don't really need to provide a solution that is exact, and sometimes you just start with the bare basics first, and then test it out which one that works best for you, and optimize it along the way. So we ended up with EC2 and realized that it's actually cost effective for us, and then we just add a trigger that will turn it off after 2 to 3 hours, or once there's already a obfuscated backup in the non-prod. So yeah, so that's kind of like a DevOps a DevOps kind of topic. And now another DevOps concept is like, yeah, for those who are not familiar with what DevOps is. So if you compare it to without a DevOps, maybe it's a long time now since, I'm not sure like how many companies are still not using DevOps, but because I started with DevOps, so I haven't really experience of how does it feel if a company is like on a traditional way of deploying a software. But with my experience is like I really experienced that cross-functional teams share responsibility. So like what I've said, so whenever there's a new application or a microservice that the developers are trying to build, so I will help them with creating the CI/CD pipelines, putting everything, the infrastructure. So when you say infrastructure, it's like where will they host their application? Do they need an image for that, or do they need security? Do they need installation? So I will help them set it up at first, and then eventually hand it over to them. So and then whenever there are issues, they will just approach to us. So it's not really like the previous one that that it's mostly like the dev will create their apps and then eventually just hand over to the QA and move to the security one by one, and it takes so much time. So with DevOps as well, what I've observed is like we do changes like 3 times or maybe daily, and then it goes through the entire pipeline. So it's like when a dev will do a change and someone will approve it in a senior level, and then it will go through a pipeline, and eventually, like if everything goes well with the testing, it can be forwarded to production even just a few days or less than a day. And with that, there's a fast recovery if there are failures in the middle. It uses it's automated because it's using AIC or infrastructure as code, which I will explain later, and it's using a CI/CD pipeline that when you push a code, it will go through a process and eventually check out some information and deploy it to production or whatever target environment you are targeting to. So if it's dev initially, and then there's another my experience was you deploy a pipeline for dev, and then there's another pipeline that is for production after the dev is being deployed successfully. What else? So the next is about our project. So it's a basic student admission form. So it's an application. It's just like a mock kind of application that we used to have at work, at Navita especially. And then it's hosted in EKS. So actually in the reality, it's usually like different microservices. And then they can be hosted in any service or cloud provider, or not cloud provider, but the same cloud provider, this different resource instead. Like they use ECS or some use EC2. But for us, this one I will be showing is the EKS. So we're gonna be using Docker container because we're gonna package the application. This is just a front-end application. Actually, if we want to move forward onto this into a real production system, we can add the back end and at the same time the database connection for each of the microservices. And then the GitHub Actions is the repository that we're going to use, which already have a CI/CD pipeline on it. And then the EKS will produce two pods of replicas and spread on 2 nodes. And the EKS is actually an AWS managed service, so we don't need to handle anything in terms of configuration and how do I say, like manual deployment. Now going back to the DevOps. So if you're a developer, or I observe with some even ML engineers that I know, or they're dealing with data, they're doing some data transformation stuff. What I observe is that they're just focused on what the task is doing, and then eventually, like, everything ends there. I'm not sure with other companies, probably it depends on what the culture the company would be, but even before, when I was an intern as a data engineer, I was just using particularly a certain Azure service, and then I was just focused on transforming the data. And I didn't know anything about the pipelines or deploying this to production. And that was the time I realized as well, like, how am I going to deploy this if this is going to be approved from dev to production, because I was doing it in non-prod. And it's just now that, like when I was practicing DevOps, where I already internalized that whenever we build applications or what do you call this, mostly like projects, we can also think about the long term. And I think it's also a good proactive sense of, proactive approach to your managers, or just, just to give them an impression that you're interested with what you're doing. And it's actually just asking questions like these ones, especially when we want to deploy it in the future to production. So here are some of the questions, like when you're building or starting developing your platform, or not the platform, but maybe the app. So you have to think about how are we hosting this application? Are we going to put it in AWS, or maybe what type of provider that we're going to use, and then what service are we going to use? So like the serverless spectrum that I've shown you earlier, we can actually use that to answer some of the questions here. And if we're not sure, we can always start with bare minimum first, and then eventually move forward to which one that works. And then, in the automation. So how do we, if we want to deploy this eventually to production, are we ready with the CI/CD pipeline? How will it look like? What types of scans are we going to put, or security measures? Are we going to use Docker? To Docker, or are we not going to use Docker? Or what else? Who are we going to use? Put some testing processes in the middle. So these kinds of automation that we have to think ahead as well. It's not that we need to answer it right away or to have it in place, but these are really good things to think about and discuss with the team. Scaling, I haven't really handled much of the scaling, but the usual scaling is like whenever we decide of, for example, deploying it on ECS, we just like create another, like scale the ECS. There's a setting in the ECS that we can scale automatically. I think it's pretty much similar to the EKS as well. And the last part is infrastructure as code. So when we build the application, we always deal with infrastructure as well, because that's where we want to host our application. So once we have the infrastructure ready, and then we have the database, for example, we have the EC2, for example, and then some other event-driven services. What usually the beginners will do, or people who are not really into the DevOps, they would always like go to the console and create it, or maybe the CLI and create it. It's not too bad, but the thing is when you are in a scale level where you have to do a lot of or manage a lot of environments, I would say, you want it consistently. You want to create a VPC networking stuff in a one environment to make sure that it's exact as for another. So probably you have 4 environments. One is dev, the other one is stage, and then QA, and then production. So there are 4 environments. So you don't need to use the console and CLI and in a way to build the infrastructure from scratch, because it's going to be error prone, and then it's hard to maintain as well. If someone will come in and then you will be moving out, it's a risk for the company in general. So we use infrastructure as code because it's mostly like a repository similar to the app code that you have, but then it's mostly deploying the infrastructure for you. And once you build this, you can replicate this to different environments, and will have consistent deployments of resources as what you're thinking about for your design. Yes, that's what it's explaining about. For another concept of DevOps is the CI/CD pipeline that, like I was mentioning earlier, is it's actually just you have a repository, so just like what you have on your application if you're a developer. So you have this application, you push the application, and then it's on the cloud. But with CI/CD pipeline, there's a feature in GitHub, or maybe in Bitbucket, that process all your steps that will help you deploy your application reliably. So with CI/CD pipeline, so the developer will push a change on your repository, and then the GitHub actions will get triggered. And there are some steps in the middle that will do the manual things that you can do, but it's in an automated way, and then eventually deploy it to your target environment. So now we're here at the topic for infrastructure as code. With AWS, it's actually infrastructure as code is where you use code to deploy your resources. So instead of using the console, for example, like clicking and going to create an EC2, we're using like common, common programming languages. Like the favorite ones that I use are TypeScript, which is similar to JavaScript, and Python. The one that I'm going to show you later is actually Python. And we use this to declare, for example, like we want to create so an application that requires a VPC, so the networking side of your application, because you don't create it like just, in the real big corporate, they used to have like a security measure for their networking side of things. So like you could create the VPC. So the infrastructure as code, you will put all your necessary resources, and then you're using Python to declare it. So there's, if you want to learn about it, there's always a lot of, how do I say, documentation out there, and it's in AWS CDK. So once this Python code is ready with all your declarations of what you want to deploy, or the resources that you want to deploy, like EC2 or EKS, this will be pushed to GitHub, and then it will trigger the CI/CD pipeline, and eventually, from that, it will convert into a template in AWS that AWS can understand. In a way, it will deploy, yes, these are the resources you wanna deploy, then we can deploy that one. So with this one, whenever we deploy things, we actually are able to see the changes. So it's like the actual, when you use, for example, when we did change from Lambda to, for example, ECS, I push the code, and there's a part where the senior will review the changes. So it's similar to an application deployment as well, but it's just deploying infrastructure rather than the application itself. Yeah, as I've said earlier, with infrastructure as code, we can replicate the declarations of resources from one environment to another without really doing so much hard work. And then there's more consistency on our declaration of our resources. What else? Yeah. So with infrastructure as code, that's what we have said. It's auditable and traceable. So whenever someone changes and there's no documentation, we can always go back to the history of the deployment, and we can track back. It's like what we do with pushing code, application code in GitHub. So the service that we're actually building today is just one particular application of the entire education ecosystem. And it may be like bigger than this, but these are just like examples of what we're trying to build, just to give you an overview. So what we're building is just the admission form for students to put up their information before they can get accepted into a college. And with this one, there's already like, it's let's say it's a microservice where it's just focused on that part of on the admission part of the enrollment, or not enrollment, but the education system. Because the student, for example, the student service, it might include some database or student profiles where it will interact with other parts of the entire ecosystem here. So with the infrastructure as code and with the knowledge of DevOps, once you can do it in one particular app or in one particular microservice, it can be replicated to others. So just imagine if you do it manually, it's going to be really risky and hard. And that's the importance of the DevOps, because like once you can automate things, it's not about like you just want to automate them because it's cool. It's because it's efficient and it's cost savings, especially for the business. What else? Okay, so the demo deploy. So the demo actually, deploying the infrastructure takes about 15 to 20 minutes, but I have recorded a video just to give you a shorter version of it. And then just to give an idea how it looks like. By the way, before that one, I want to show you how the structure of the code would look like. Usually, like with projects I've worked on, and especially when they have a CI/CD pipeline and all the application in place, it's usually like they have the pipeline, the CI/CD pipeline on this side, and then the application folder, and eventually the infrastructure folder. Because when you say the application folder, over there, it's more of like the application code. So that's where the developers are mostly dealing with, like back-end, front-end database and stuff. It's more on the application side. The infra side is where you declare or you use the resources that going to use for your application. So if you can see here, since we are deploying the infra and we're using EKS and CDK, so yeah, that's why there are the declarations are here. And the application is just a simple front end at the moment, but if you want to move forward, it can be a lot of pages depending on the microservice that you're building, and then the declaration of the databases as well, and then the back-end service as well. So this is how the CI/CD pipeline will look like. So just to give you an idea, it's a YAML file, and then it's saying that whenever a user will want to push to main, this is just an example, like on a certain branch, we can declare that whenever a user wants to push on a certain branch, this one gets triggered. So these are like the steps that needs to go through whenever you want to. So the input will be the git push, and then the output will be deployment. So these are the ones in the middle. So it can involve logging into your account and then eventually accessing some resources. For example, like the ECR. Like ECR is actually an image repository if you're using Docker, and then it will do some processes in it. And a bit of it is also doing testing and scanning if it's in the real like production system. What else? Yeah, and some other configurations. So if you will look at it, some of the configuration here are actually not like hard-coded, because actually when you're working with GitHub or any repository, they have a set of settings where you can store all your details when you're doing deployments. Just to give you an idea as well for people who haven't worked with GitHub Actions before. I think it was secrets. Yeah, this one. So this is where we store our like deployment variables if we need to. But yeah, so this code reflects to this repository, and then the trigger of the GitHub action is actually here in the action. So whenever there's a push to the main, then this will get triggered and will deploy and go to access the AWS account and do the necessary things that needs to be done to deploy your application. Okay, I'll show you the demo of the deployment of the entire application. And it's here. Where's that? Yeah. So first, we need to deploy the infra. So the first thing, when I was still doing this project, I manually deployed the infra. So when you say infra, it's like the EKS, the VPC, the what else? These are the security groups and stuff. So these are the things that are required for this project. So I have to go to the CLI and then start it and create the clusters as well before really pushing the code into the target hosted, the target host. So what I did is I went to the CLI, did some configurations using the CLI manually, which is in the real world, nothing should be done on the CLI. It should be automated. And then we try, it's not like we make everything zero, just a click ops, but it's mostly like we reduce, automate the deployment of the, how they say, of the application without really going to the CLI. So I tried to deploy it, and then I realized, like, yeah, we can actually do it. And so I just followed the steps of what I did in CLI, but then put it in an automated pipeline in a way that it will go and log into my account, and then it will create the configuration, and then it will set up all the VPCs and networking stuff for me, and the EKS as well. So if we're gonna do this manually, just before showing you the actual setup, so if we're gonna do this manually, I'm gonna be, okay, yeah, oops. So I'll be manually going to the VPC and create the VPC by myself, or maybe just go to the CLI and then follow a code that will create the VPC for me. But this is not the only resource that I'm going to use. So that means I'm going to create the EKS as well. So that's like very manual. So what we're trying to do here is, like, whenever I just do a push, then that will just create everything for me. So that means if I want to do this in one environment and I want to replicate the same environment, the same setup or configuration for a different environment, then it's just like one click. So it creates a VPC, for example. So when we do that, it's going to take some time. But with automation, so what we do is for the infra, with the CDK, this is actually, before actually I'm going to show you how the deployment will be. So the CDK is where you declare, as I've said earlier, declare all your resources. So this is the stack that handles all the resources for my infrastructure. And I'm using Python here. So if you will see, this is my application infrastructure. And for example, this one, it creates the VPC, and then it creates the ECR for me. It also creates some roles and the cluster that are necessary before I am able to push my application code to the infrastructure. And if you can see, this is also really good, and especially when you're doing, it reminds me now, when you're doing disaster recovery. Because once you have this, if the company, whatever, something happens to it, then you always have the infrastructure as code ready, and you can just deploy it maybe in another region or another account, something. And yeah, that's somehow like very useful for the security team or disaster recovery team to have this kind of infrastructure setup. So these are the resources that I was talking about. So when we deploy this, it's gonna create all those services. So I'm going to show you how it will deploy. It's about 4 minutes. So at first we need to go to the infra, because it's the CDK is there, and then we're just gonna be installing the requirements, since it's a Python-based CDK code. I'm sorry, it's not too big, but I'm following that instruction. So once, assuming that you have the account bootstrap. So bootstrap is like you're making your account or making your VS Code ready. Oh no, sorry. You're making your account ready to deploy using CDK. So prior deploying this, there are some preparations that you need to do to your account, and as well as to your VS Code. So once we deploy this, if you can see the CloudFormation section of AWS earlier, it was empty. So what we're trying to do is we want to deploy the resources, and then it will be converted into CloudFormation before it becomes and deploy into the actual resources that we're trying to build. So right now, there's nothing here. Once we deploy this, it should be showing the different resources. Yeah. So once we CDK deploy, especially on this side, it will give us the different resources that it's gonna build for us, or the infrastructure. Maybe I can show it here, or maybe it will take some time. So we will do a CDK deploy now, and once it's deployed, it will look like this in CloudFormation in AWS. So it will create the CloudFormation change set, and eventually it will deploy us. So that's as the application. So that's where the stack will be deployed, and in the stack we can find all the resources inside it. So there we can see the VPC, the ECR that I was mentioning earlier in the code, and yeah, it's deployed all together here. So that's just for the infrastructure. Now I'm going to show you when we deploy the application. So this one, since this is an EKS application, it takes about, I was mentioning earlier, 15 to 20 minutes to deploy everything, because it's deploying the VPC and it's creating some networking configuration like the ENI figures there. And that's why it's taking some time, plus the EKS itself as well is also taking some time. Once that is being deployed, so we already have the stack here. So at the moment, if we go to CloudFormation template, we can see all the stacks are actually present. Sorry, this internet is a bit slow. Yeah, so this is the stack, and these are just like, because it's Kubernetes, it requires some custom stacks that needs to be created and as a support to this main stack. So here we're just creating the Kubernetes cluster and other networking parts of the application. So this setup, this pattern, we can actually use Lambda. So instead of Kubernetes, we can instead put a Lambda there, and it follows the same pattern where an application is hosted in a Lambda, or a simple, maybe not a complex application, maybe just a simple application. It can be hosted in an ECS Fargate instance, or maybe an EC2. It's very similar approach on how to deploy it. So now we already have this infrastructure ready. So we want to push the code, the application code, to the infrastructure, which is actually on the EKS cluster. Just to show you how it looks like, EKS cluster. Yeah, this one. Resource. Maybe we can go to EKS. It's easier. Sorry, the internet is a bit lagging. I just see your clusters here. it's a bit slow. So just to show you now, we're going to be pushing the application and deploy the application with the ALB at front, without the cloud front yet. And then it's a bare application, and then it's hosted in EKS. Yeah, so this is the cluster, and this is how the EKS would look like inside. So the EKS that we're building is actually a group of EC2 instances inside it. We're not using the EKS Fargate. I haven't used that as well. I'm more familiar with the EC2 EKS. Anyhow, so we're going to be pushing the code to, which is a very usual thing that we used to do whenever we're dealing with in a production setting, that it has to go through from a branch account and then push to main, and it needs approval from senior or maybe other developers to check the code changes. And once we merge it, that's where the CI/CD pipeline gets triggered, because since our pipeline is actually set to that branch, to the main branch. So once we merge this, if we go to the GitHub Actions, it will actually show us that the pipeline is being triggered. So with the pipeline run, we set all the different instructions that it needs to go through. Like I've explained earlier, that it will go through the ECR and login, and then build the application, and then put it in the container. The container will be pushed to the ECR. So these are the series of steps that it will go through. And then once it's there in the ECR, it will be used to push or place into the AWS service, which is the EKS. And this is going to be the process whenever we do changes on the application side of things. So when the developer now is ready to make changes and like adding a button or changing some configurations on the application, then this eventually will get triggered all the time, especially when it's pushing to the main branch. So that's the image URL. So if we go to the ECR, this is how the ECR would look like when it went to that image. After that, it's deployed to Kubernetes, and now there's a load balancer in front to show us like that it will get exposed to the internet and then give us the actual application. So we took the URL of the load balancer. So the load balancer is the one that takes the traffic and divides the traffic, spreads the traffic across all the different application routes, or if there are like different pages within the website or the application, the load balancer will be the one who will handle that. And we're just using the load balancer for now instead of an actual URL, because this is just a demonstration anyway. So right now it takes a bit of while to really do the actual to get the actual page, because it's picking up the IP address. So after like 2 minutes, we were able to get that URL and make it work. So for example, if I will go to, so here in the current, because I ran it just today. So if we look at the URL of the load balancer and check it, so this is how the app would look like. So yeah, this is the admission application that we're trying to build. So this is just the front end. So if we want to add more backend on it and the database configuration, then that's the application folder where we can add all the necessary code. And then, yeah, whenever we push it to the main branch, then it will get triggered and changes will appear here. But for example, when my observation as well, when devs are working on a certain feature, they don't push it right away to main. So what they do is they try to trigger it to a certain branch or the branch that they're working on. And in that way, they can test how the application is looking in the first place, and then before they really deploy it to the main branch. What else? So I think that pretty much concludes my presentation for tonight. I hope you have learned something from a DevOps perspective. And if you have any questions, feel free to ask. Yes, please.
Just 3 questions. So, in your configuration, I saw the finally public domain name without SL certificate.
Yes, yes.
If you want to configure in the step, which step you need to do?
In the architecture, as we did I show the architecture earlier? It's actually a load balancer on the front, and then at the back is the EKS. In a real scenario, there's an actual like CloudFront service that handles all the necessary configuration for domains and certificates as well. So we can still add those in because that's infrastructure. So that means we need to redeploy the infrastructure again with the additional configuration for the SSL certificate for the new additional resource. Yeah, that's it.
My second question is about, I saw the CI/CD pipeline of GitHub Action.
Yeah.
You only run push on main.
Yes.
Would it better add to when pull request? Since I think once your code merge, once your pull request merge to main and trigger the flow, at that time your changes already merge into main. But what if the CI/CD pipeline failed?
Yes.
So maybe if we trigger create a pull request, and once the CI/CD passed, and we can merge it to main.
That's a really good question, because actually in practice, in reality, I mean in a real team, you will actually decide how you wanna go about with what you're comfortable with. And the one that you've been mentioned earlier is actually like the one that I have practiced before, where the pull request, it has to be done before merging. And mine is more of like a basic one in order for for people who haven't experienced much of this to understand right away of the CI/CD pipeline. But there are a lot of optimizations that need to be done on the pipeline itself. So this is just the bare basic for the setup of deploying an account an application from scratch, from infra to application. Yeah. Okay. But good question.
My final question is about, I saw you created VPS after...
VPC?
Yeah, VPC, sorry. Immediately using Python, would you consider to use Python virtual environment to specify the Python version? So I imagine sometimes our project will change over time, like upgrade the Python dependencies packages, which requires to use different version of Python.
Yeah.
So my question is, so can your application and the infra, the installation, work under virtual environment?
Yes. In your deployment YAML file, for example, in your CI/CD pipeline, it's like an actual, when you go into your computer and install the VPC one by one. So that means whatever you want to add, like since you're upgrading, you can also add it as a step here on upgrading it, or you can, if it's like a one-time upgrade, like once in 2 years or something, then I'm not sure like how you're gonna do it in terms of the Python, because I haven't experienced that. I'm mostly like upgrading the OS operating system EC2. And it's done through the YAML file configuration. Maybe someone from the audience here who have experience upgrading the Python. But if you want to deal with the upgrades, you can add a step here in the CI/CD pipeline to do the upgrade for you.
Thank you.
Yeah.
If you're using Lambda, you can tell directly AWS which Lambda versions to.
Yes, because Lambda is an infrastructure, right?
Yeah.
So it's not in the CI/CD pipeline. It's mostly in the declaration of your stack,
Yeah,
so of the resources. So
And if you need to update, you just make a declaration here.
yeah, you just update that, and then you go through the process as well. Actually, it's a bit more complex in ours because we have the infra, and what we did is the CDK deploy. But actually, we also have a CI/CD pipeline for the infra itself. Because what I've shown you earlier is just the pipeline of the application. The infra, we deployed it like still manually. But as I was saying, like we improve it along the way. And if the company has a process, then you just follow with that, and if there's no process, then you start with that one, deploy, and then eventually go to a CI/CD pipeline just for the infra. That whenever you want to add resources, like the one you've said, the cloud, the CloudFront, yeah. So that's infra change. That means we do a CDK deploy. It's really good to put another pipeline for that part. Any more questions?
I've got two questions. So the first one is related to what you just said. So you have two pipelines in parallel, right?
Sorry?
Sorry. So I assume you have two pipelines.
Yes.
One for the infrastructure and one for the app.
Yeah.
How do you map the two? As in, like, once your infrastructure is ready, how do you declare it for your apps? Because that's going to be deployed to the infrastructure.
Yeah.
But it's been freshly created. So how do you map the two?
When there are two different deployment, you will set up a configuration where when it's triggered from the infra repository or a infra branch, then the one pipeline will trigger it.
Yeah.
And then if it's an app change, then it's the other pipeline.
Once you have the infrastructure ready,
Yeah.
do you have to manually put that stack or those IDs in the app repository?
Which IDs? You mean?
As in, like, if you have created a new EC2
Yes.
or a new EKS,
Yeah.
how do you tell to your
Okay.
app pipeline to deploy there? Because it's new, right?
Yeah.
How do you map the two?
It automatically maps for us.
Okay.
Yeah.
In that stack.
Yes. Yes.
That was the first question, and the second one was, how do you manage costs? Or who does it? In your experience, is that in your team to manage the cost of all that stack? Or is your manager managing the stack and telling you that's a bit too expensive?
What my experience is usually, because it's mostly dealing with operation tasks. So what we do is like obfuscation. So obfuscation is not really something like you build an app and you let it be there for a long time. So obfuscation is a task where it will just perform within the 3 hours of, like, say, once a week, if you prefer, or maybe once a day. So with that 3 hours, usually when we automate things, it's already something happening manually. So when you do the costing, you compare, like, how do you spend time and the person that's managing it manually versus if you automate this. Just in that way, I think it's already a win-win for you. Yeah. And another way in costing, as I've said, I would say usually they will have a budget, and definitely if you want to run things, you will be that's why I was saying the serverless spectrum, you will start with a very bare minimum resource first and see how it goes, and then eventually you optimize first probably with performance if it does the job for you, and then eventually do optimize the cost. Of course, you won't be starting with EKS at first because it's really expensive. Yeah, sorry. Another question? Sorry.
For infrastructure as a code, we need to keep all the settings and configuration of our containers in a special declaration in the repository. Is there any way to do it automatically, synchronize with the environment and put it in the code? Because we have to keep it in our mind. Whenever we change the setting, we need to put it inside the declaration as well. So is there any automation for keeping all these settings?
Can you explain further, like, for example, you want to add an environment variable? Is that what you're trying?
Yes, something like that.
With the repository, we have this environment variable section, as I was saying. So for every repository that you have, there are some different configurations here that you can set up that can be used. If it's a secret, then you can add as a secret. And then if it's a normal, regular variable, then you can add it as a variable here. I haven't really gone, or I cannot remember because we're using Bitbucket right now. So it's been a while that I haven't used GitHub Actions when it comes to like making changes on the configurations. How do I say? Or maybe some of the audience might want to answer it. Help.
Another solution you do is like you store things in setting variables or secrets manager. So you structure you could create things, store them with a common path, like a single path that is where that describes where that application will go and find those variables.
Or you can use the vault in AWS.
Yeah, or the secrets manager as well. But in terms of like what I got confused is what like you were saying, like the history of the changes of those variables. I think that might not be that's not trackable as well because you have to change it manually, and then it will just change the environment variable inside. For example, if you're storing in a SSM parameter, or in a secrets, or in a vault. Because it's also not a good practice if you will put the environment variables inside the GitHub repository where everyone can see it.
Not secret.
Yeah, in that way, just for you to see the history changes or something. But yeah, the practice that I've observed is, they put it on SSM parameters, and if it's a secret or like database information secrets parameter, I haven't used Vault. And then, here as well, you can add on some other variables that you want to use for your GitHub pipeline if you need to, if you want to use, or if you don't want to hard code it in your pipeline. Or if you want to reuse it as well, like if I want to deploy this in a production, another environment or another AWS account, I will just put the account here and then create a step that it will deploy to another account. Any more questions? Oh, okay.
So with the batch obfuscation job that you spoke about previously, you've talked about the evolution from ECS Fargate to EC2.
Yeah.
Have you thought about any other cost optimizations you could do there? Like are you using reserved on-demand instances or
no?
Instances?
We did not go through that level anymore because we thought like the EC2 is as well is, but actually that is a good a good discussion with the manager or with the team that if we want to optimize the cost, just to make sure to see like how much difference in terms of like savings that we can do. But it's a 3-hour. I haven't used Spot instance actually, so it's a 3-hour task. So probably it can save a bit, yeah.
And now you can use the cost explorer and whatever in AWS that tells you which changes you can do because it analyzes your infrastructure and tells you, okay, if you change these and you take this kind of contract, it's going to be better.
Yeah.
You probably wouldn't want to use a Spot instance, right? Because if you get halfway through the job and you've got to tear it down, it's probably not.
It's not, the instance is not torn down. It's just like there, but it's we put a trigger that will turn it off once we see that there's a obfuscated backup created in non-prod.
Yeah, just people know the idea.
Yeah.
Because if you use a Spot instance, you could have to tear down at every point.
Yeah, and then create again and build the entire environment back again. And the chances of having errors might be higher than just the same EC2 instance to use.
We'd probably do it with Graviton too, and say you don't know.
Yeah. Any more questions?
You just mentioned that when we push our code to certain branch before, before we merge that branch into the maybe main or release branch,
Yes.
It can maybe in the real practice, it can trigger another maybe concurrency environment.
Yes.
My question is that how do we manage the concurrency environment? Maybe like the requester maybe send to I wanted to send to the concurrency environment.
Yeah, or a parallel environment. Yes. I've seen those kinds of deployment before. If you say like how do we handle it, like if it's a parallel pipeline.
Maybe I don't want to impact. Like,
yes, for management, if one pipeline will break and it won't affect if it's a parallel, but then like the error will be looking onto that pipeline, and it depends of if you set it up as like something that will not go through or will go through if there's an error. Most likely it won't go through because it's supposed to pass, because like parallel can be just a task that will help the entire process to shorten the time instead of going through the entire task at once in one pipeline. In terms of, I was saying like the management, there are some parts where you can add approval for the pipeline to go to the next step before before it goes through the next few steps that it needs to.
My question actually is more.
Okay, I think I understand his situation. He has an application online. It's over 100,000 users online currently.
Yep.
So he doesn't want his application to down.
Yes.
So he just want to do zero downtime upgrade. So when his instance running, so once he trigger the pipeline and push the new release binary to the cloud, he don't want his existing running instance to getting down. So maybe it's like a rolling the old to and pushing the new to the create.
I think that would be a different approach. There would be a different approach to that. Like there's like we call in AWS a blue-green deployment, or some kind of, it won't deploy unless if it's successful. Like it will retain whatever is the actual live site right now before the changes won't be going to that one right away. And then there's this part which I haven't really got into the hands-on side of things, but it's mostly like they call blue-green deployment, where you will deploy still to the live site or to the live audience, but just a certain number of audiences. And that's where you can check if your actual live site is actually working. But then maybe 70% of there's another environment, 70% of the traffic goes to still the old one. And then once you're happy for a few days, probably with the 30% that it's working, or maybe not the scaling in terms of the traffic because it's just 30%, then you can convert and remove the old one, and then eventually the traffic will just go to your new one. Is that the one? Did I explain it correctly?
Sorry. Actually, that is not my question.
Okay.
I didn't make it clear. My question is that during the development phase, and I just want to do some test in my parallel environment, not the release environment.
Yes.
I don't want to impact other teams.
Yes.
So I want to maybe I do some test, just send this request into the specific parallel environment.
Okay.
I trigger that pipeline which release that environment.
One way is, do you want to deploy it in the same environment as there? So for example, are you referring to an account or AWS account environment? Because like, for example, dev is different from production environment. We don't combine them. That's my observation. So the dev team will just work in the dev once they're building the application. And once it's done, then they move it to another environment, which is the stage. And some even have QA step, but for us, we just like have the dev and then stage and then eventually the production. So there's nothing much development going on the stage and production, mostly on the dev. So And then all the configuration, like the AIC, is very similar, and the code base is similar to what we deploy in QA or in stage or in production. So if you want to test out only, and because you're wanting to test out, it should be a different environment, AWS.
So that's a branch.
And then
that service, not the relay service. Yeah. Is there any way to manage maybe during the test phase, managing my requests just happen in that environment, that service?
Yeah, possibly it can be, because like you can trigger your pipeline to a certain environment, and there's a setup for that one. I've seen a few of it before.
Oh, thank you.
Yeah.
So we can give.
Oh, okay.
So we'll have another speaker next month. Certainly, if you have any questions, myself or Jura will be able to answer them around what's coming up. Hopefully, some pretty exciting stuff. But if you'd like to give a talk at all, just come up and see either of us, or at the next meeting, and send us through a rough synopsis of what you'd like to talk about, and you too could be up here delivering a great talk. So thanks again.
Thank you. I hope someone learned something from the talk.